some applications of the okay. Chapter 3, applications of differentiations. Okay. So in this chapter, we talk about the maximum and minimum problem. Okay, relative maximum and relative minimum, and absolute maximum and absolute minimum. The second, absolute maximum and absolute minimum. Maximum and minimum incomes and infinite, and marginal value and elasticity. Okay, and last, implicit differentiation and related breadth. Okay. We now today we move to the first lesson. Lesson 3.1, maximum and minimum problem. By the end of this lesson, you will be able to understand about the two methods to find the relative maximum and minimum values of the function one variable. The first is using first derivatives, using the first derivatives to find maximum and minimum values. Okay, and the second method, using the second derivative to find maximum and minimum values. Okay. Now we move on to the first part, definitions. Okay. So in the life, we need to find the profit maximizing and cost minimizing and risk minimizing efficiency portfolio and optimal inventory. And so that you know, the profits always equal revenue minus cost, and revenue equal price by multiplied by change, and price is given the products under competitive market. Now we have a definition. What is the critical value? A critical value of the given function is a number C. The first condition, C belongs to the domain of the given function, and at the C, f prime at C equals 0 or does not exist. F prime at C. F prime at C does not exist. Okay, that means the tangent line at C is a horizontal, because this is a horizontal. This is tangent line here, horizontal. That means the tangent line parallel the OH axis. Okay, it's called the tangent. Because the tangent line parallel the OH axis, that means so we line f prime at C equals 0. Okay, and the slope equals 0. Okay, a critical value. So let me give you an example. Find on the critical of the function y equal square root 2x square minus x. Okay, critical values of the function y equals square root of 2x square minus x. Okay. So before you find the critical value, you need to find the domain. The first step, you need to find the domain of this function. Domain of this function. What is domain of this function? You need to solve inequality. 2x square minus x is a positive equivalence. Is a positive or equal 0. I mean, x is less than 0 or equal x less than or equal 1 second. Okay, that means the domain of this function is the set from in minus infinity to 0, union from 1 second to plus infinity is 0. The domain of this function. And you find now you differentiate the given function. I mean you find y prime equal what expression? Y prime you apply the formula the square root of 0 derivative equals 0 prime over 2 square root of 0. Okay, and equal what expression? Now can you read for me what expression?
Point minus 1
Point minus 1
over
Okay. 4x minus 1 over 2 square root of 2x square minus 1 minus x. Okay. And you solve the equation. Y prime equal 0. Y prime equal 0 equivalent 4x minus 1 equal 0 equivalent x equal 1/4. Okay. Okay. And you have x equal 0 or at x equal 0 or x equal minus 1 second. That means we have y prime at 0 does not exist or and does not exist y prime at 1 second. Okay. What conclusions do you have? What conclusion do we have? According to the definition, you conclude how many critical values of the given function how many the critical value, that means the number C belong to the domain of the given function and it satisfies f prime at C equals 0 or f prime at C does not exist. Okay, have a two conditions, one of two conditions. What conclusion? Oh, 1 4. Is it 1 4 is critical value or not? X equal 1 4.
No.
Why? X equal 1 4 is not critical value. Why?
Because it doesn't belong to the domain.
Yes.
And just add the
Only one
definition.
reason. Only one reason. Okay. And so you this number does not belong to domain. So we imply x14 is not critical value. What about the 0 or 1 second? One second. Number 0 is a critical value or not?
It's critical value.
Yes. Okay. So we conclude that. We conclusion. The given function has two critical values and x equals 0 and x equals 1 second. Okay. Although x equals 1 4 derivative of x equals 1 4 equals 0, but 1 4 is not belong to the domain of the given function. Okay.
Professor,
So yes.
what critical value in Vietnamese means in Vietnamese?
Okay, so critical value. Equal. Okay, same meaning. The critical value equal has two kinds. Stationary point. Stationary point. That means okay. Equal x number c is a stationary point. That means the y prime at c equals 0, and the second y prime at c does not exist. This is a critical value. Critical value or critical point. Okay, critical point divide into two kinds of. Okay. If so, we have each example. Can you give me another example? If y equal x cube minus 3 minus 4 x square plus 5 x plus 1. Okay, you find what is the domain of this function? Domain.
R.
Domain equal A. D equal R. Okay. The letter D. Letter D is abbreviated by domain. Abbreviated by domain. And so we have a y prime equal 3x squared minus 8x plus 5. Okay. And in this case, you find y prime equal 0 equivalence 3x squared minus 8x plus 5 equal 0. Okay, equivalence x equal what number?
1.
1 and x equal 5 of 3. Okay, and in this case, 1 and 5 over 3 belong to the domain of the given function. So we conclude that the given function has a two critical point. And in this case, on its critical point are stationary point. Belong to the stationary point. Why do we say that stationary point? You see on the picture this graph of this y equal fx in here. In this point is 1 and this point is 2. This point because the y prime is 1 equals 0, and that means the slope of tangent line of this curve at this point is horizontal. Okay, that means this tangent line parallel the OH axis is parallel. And in this case, you move to on the pebble in here. So you in this point is called the stationary point. And in this case, the same stationary point. Okay. Because this is move upwards and move down. That was this point. It is fluctuant in this point. Fluctuant. Okay. What another question? Have you another question? Okay, now we move on to another definition. Let D be the domain of the function f. Fc is a relative maximum minimum if there exists an open interval from C minus delta plus C plus delta such that this satisfies. Minimum, relative minimum. What does it mean? Relative minimum?
tiểu.
So that means okay. So you need to distinguish between the relative minimum and absolute minimum. Absolute minimum is the same meaning. Okay, so you need to distinguish between the two concepts, relative minimum and absolute minimum. Okay, you can see this picture. Y của fx in here. If we consider on the closed interval AB in here, this point, C is called the relative minimum, but it is not the absolute minimum. Okay, relative minimum because there exists the open interval from C minus delta and C plus delta. Okay, and in this interval, we touch on the value any one in this interval, anyone in here, is in here. The value of fx is f at c, and the value of fx on y less than the value of fc. Fx on y less than fc. Okay, and we say that fc is relative minimum values of the given function. Okay, and in this case, the open interval C minus delta, C plus delta, it is called the neighborhood of C. Okay, that means neighborhood of C. Okay. So I mean the given function has a relative minimum at C. It satisfies three conditions. The first condition, number C belong to the domain. C belong to the domain of the given function. And the second, there exists an open interval. It is a neighborhood of C, such that the value of given function at C less than all the value of given function at another point in this neighborhood. Okay. Okay. Now, similarly, you have the definition relative maximum. Okay. You write this definition relative maximum. Fc is a relative maximum if there exists the open interval, the subinterval B1 in the belong to B, that's Fc less than Fx. D1 is called the neighborhood of C, the neighborhood of C. Okay. see this picture. In this case, we said that the given function has the relative minimum at A and C, and it is a relative maximum at B and D. And D. Maximum. Okay. So, relative maximum or relative minimum values, we say it there has a common name is a relative extreme. Relative extreme. Okay. Relative extreme. Okay. For example, in this graph, this boy is absolute maximum, and this boy is a relative maximum, but it is not absolute maximum. Absolute maximum at B, that means FB less than Fx for on x belong to the domain of this function. Okay, is the absolute maximum and absolute and Fx is a relative maximum at C2. That means F C2 less than Fx for on x not belong to the domain, belong to the sub interval. That means we say the neighborhood of C2 neighborhood it is right, C2 minus delta, C2 minus plus delta. In this interval, we take the h in here, the value of given function at C2 less than the value of given function at fx in here. Okay. In the fact that the value of given function at C2 is a absolute maximum in sub-interval. That means only consider in the neighborhood of C2, not domain of C2. Fx. Okay.
Thầy ơi,
Yes.
thầy ơi, em là Kim Anh ạ. Thầy ơi, bây giờ em phải đi tiêm rồi thì thầy em xin phép nghỉ sớm ạ.
Okay.
Dạ vâng ạ, em cảm ơn ạ.
Now, we move on to the second part. Using the first derivative to find maximum and minimum values. So in the first part, we have three definitions. So we have three definitions: critical value and relative maximum and relative minimum. Okay. And the second part, using the first derivative to find relative maximum and minimum values. Okay. Now we have this theorem. You write. Theorem 1. F right x is positive for all x in an open interval. Then f is increasing. Okay. And f right x is negative for all x in this interval, so we write f decreasing. Okay. And the decreasing or increasing, we say it's monotone. Increasing or decreasing, we need to use to determine relative maximum and minimum value, increasing or decreasing. Okay. So you can write this. It's zero in here, plus or minus, that means increasing or decreasing is F prime. And the second is zero and minus or plus in here, F prime. Okay, so okay. So we can find. Okay, we have the second definition, second theorem. If a function f it has a relative extreme of value ft extreme value on an open interval, then c is a critical value. That means the given function fx y equal fx has relative maximum or minimum values at c. Then we conclude that f prime c equals 0 or does not f prime c. That's two conditions. If the given function has a relative maximum or minimum values at c, then f prime c equals 0 or does not exist f prime c. Okay. The third theorem, for any continuous function or continuous function which the value at c belongs to the open interval ab, then the function f has a relative minimum. Okay, minimum value. That means this has formed a c in here, and on the left side of c is a and b. On the left side from a to c is a negative. On the right side is a positive, and we have a this is a decreasing and increasing. This is a minimum value. Okay. So first and the second c in here from a and b. On the left side of c is a f prime h is a positive. And on the right side is a negative, that means increasing on the left side and decreasing on the right side. So we imply this is a maximum. Okay. This, and the third conditions, the third conclusion, f has neither a relative maximum nor a relative minimum. C. If F prime C has the same sign. The same sign. That means F prime is unchanged when it's true number C. That means the same meaning. C plus plus or C in here minus or minus in here. F prime. F prime is the same sign on the left side and right side of C. Okay. Now, it's you shown for me this example. From this theorem, how many steps to solve? How many steps to solve the problem? Find the relative maximum and minimum values of the function. So you write. Find the relative maximum minimum value of the function y for fx. How many steps? Solution. The first step, you find the domain. Find the domain of given function. The second step, is called the necessary condition. Necessary condition. In the necessary conditions, you find f right. Okay, then you find on the critical value. On the critical value. Okay, and the third step, is called the sufficient condition. Sufficient condition. You in the sufficient conditions, you consider the sign of f right. Okay, and you have this formula. Assume that C is a critical value, C1, C2, etc. And at number C in here, F right is on the left side is the negative and on right side is the positive. Okay, in this case is a minimum value, and C on the left side is a positive, on right side negative is a maximum. Okay, so we and the last step, fourth step, conclusion. Okay, and in order to solve problem, find the relative maximum and minimum values of the given function by using the first activity. You need to solve 4 steps. You need to solve following 4 steps. Okay. You write this 4 step in here. Very important. now you solve for me this example. I give you 10 minutes to solve 2 questions. You finish the first question. Okay. Nguyễn Hải Yến, can you talk to me about the question A? Nguyễn Hải Yến, do you hear me? Nguyễn Hải Yến, do you hear me?
I'm here.
Now can you talk to me? How to solve the question A? What is domain of the question A? Domain. The first step, you need to find the domain. D equal
0, 5.
domain D equal R the second step. Necessary condition. Necessary conditions. Okay. F right. F right equal 3 square minus 2x minus 1. Okay. How many critical value? How many critical value? F right is equal 0 equals 3x square minus 2x minus 1 equal 0 equal x equal what number? X equal can you talk to me? Mai Hương.
I'm here.
H, you saw this. How many solution of this equation?
I think x equal 1
One.
and x equal minus 1 over 3.
1/3. Okay. Minus 1/3. You sufficient condition. That means the given function has two critical value. Okay, and you establish the table x, f prime x, and fx in here. Minus 1/3, 1, 0, 0 in here, and we consider the sign of f prime minus plus in here, and increasing, decreasing. Okay, and at last step, conclusion. One step, two step, three step, and four step. Okay, conclusion. How many conclusions do you have? How many conclusions do we have? The first conclusion, you need to conclude that the given function is increasing on this interval. What interval? Increasing on from minus infinity to minus 1/3, and 1 to plus infinity. Okay, is increasing on this interval, and decreasing on minus 1/3 to 1, and the last conclusion, the given function has a relative maximum at this point, maximum at minus 1/3, and its maximum value equal f at minus 1/3, and the given function has a relative minimum, and its minimum value at f1. Okay. We solve this. Now, similarly, you solve for me the question B. Question B. Okay. So I give you 5 minutes. After 5 minutes, you can talk to me how to solve this question. Phạm Thanh Tùng. Phạm Thanh Tùng.
Có.
Now you read for me. What is the domain of this function?
X.
Domain D equal the value of all real number except what number?
Minus 4
4
over 3.
Okay, and this domain necessary condition. Necessary condition y prime equal what? Equation
2
2 e power
e
2x plus 1 times
3x plus 4
dot 4
minus e
3
over 3x plus 4 power 2
power 2 or square and
square.
go
And
y prime equal. We take the calculator outside. E power 2x plus 1 times
time 6x
6x
minus plus 8
8 minus 3 equal what number?
5
5 over square. Okay, and in this case, domain of y prime the same domain of the given function. So you only solve the equation y prime equals 0 and e 2x plus 1 times 6x plus 5 equals 0. Okay, and because the exponential function on y equals positive, 6x plus 5 equals 0 and x equal minus 5 over 6. Okay, e 2x because e 2x plus 1 on y positive. Okay, and the sufficient condition, the third sufficient condition. So you establish the table x f prime fx and equal plus minus 5 over 6 minus 4 over 3 minus 4 over 3 minus 5 over 6. This is a undefined and 0 here. Okay. So because the y prime x equal this equation and because the exponential function e power 2x plus 1 on y positive and denominator is a square. So we on y positive and y prime only depends on 6x plus 5 is a linear function. And on the left side is the negative, on the right side positive. Okay, and here minimum. Okay. Last step, conclusion. The first conclusion, the given function is increasing on open interval minus 5 over 6 to plus infinity, and the given function is decreasing on minus infinity to minus 4 over 3 and minus 4 over 3 to minus 5 over 6. Okay, and the third conclusion, the given function relative minimum at what is equal minus 5 over 6, and it is its minimum values. Its minimum value equal fx with fx minus 5 over 6, and you evaluate this number. Okay, there it is. The first condition, u on y present 4 steps, 1 step, 2 step, and third step, 4th step. Okay. It is the method using the first derivative to find the relative maximum and minimum values of the function 1 level. Okay, do you get it? Have you any question?
No.
No questions? Okay. Okay, no question, so I will
Stop.
change options. One,
Yes.
Kim Anh, Đào Kim Anh.
Thầy em bạn 10